Hello, this is FlippedHarber for Algebra 2. In this video we'll be covering section 5.4, completing the square. Our objectives for this lesson are to solve quadratic equations by completing the square and to write quadratic equations in vertex form. The outline for this video, we'll talk about the square root property, solving with the square root, we'll look at completing the square in equations and completing the square in functions. The square root property simply says that we can solve a quadratic where there's no x term by just taking the square root of both sides. Now, when we do this, we want to make sure that we're including both the positive and the negative square roots. So to solve this quadratic, again, there's no x term. I'm just going to move the 15 over by addition. So I get x squared equals 15. Now, I just take the square root. X equals both positive and negative the square root of 15. And this is a great way to write it. The square root of 15 is an irrational number. It doesn't work out nicely. There aren't any perfect squares hidden inside the 15, so I'll just leave my answer like that. Don't type it into a calculator and get a decimal approximation. Let's take a look at another nice example that will work out properly. I've got x squared equals 9, so everything is separated out. I've got the x squared on one side, I've got the 9 on the other. Go ahead and take the square root. I've got x equals both positive and negative 3. Don't forget to include both the positive and negative solutions. Now, taking a look at this one, what makes this a little bit different is that minus 2 in there with the x. Now, we'll be taking the square root still to get rid of the square on the binomial. Before I do that, I'm going to move the 16 over by addition again. Taking the square root, I get x minus 2 equals positive and negative 4. So now I just deal with the 2 by adding it over, and I'm going to get two solutions. I get the two solutions by breaking it up and setting x minus 2 equal to negative 4 and x minus 2 equal to the positive 4. I get x equals negative 2 or x equals 6. Let's try that again with another example, one a little bit harder by having this multiple in front of the binomial. Now, the way we'll deal with this, we'll start by moving the 12 over. Now we'll deal with the 3 by actually dividing by the 3. We want to do this division before we take the square root for two reasons. One, we don't want to be trying to take the square root of anything goofy. The square root of 3 is goofy. And it's going to make this one in particular something nice, because now when I take the square root of 4 works out nicely. I have x minus 2 equals plus or minus 2. Again, this is going to give me two answers. I add the 2 over, and I get x equals 0 or x equals 4. Now, completing the square, I want to take advantage of how easy it is to solve with the square root. This is a quadratic with a b term, with that 4x in there. Now, the way I'm going to make this something nice is I'm going to focus on this 4 real quickly. I'm going to add half of this number squared to both sides. So I'm going to add 2 squared to both the left and the right side. Now, I leave it as 2 squared to kind of remind me of what the binomial is going to be in a second. On the right side, I just go ahead, 2 squared is 4. So I just add 4 to the other side. Now, that's going to factor into x plus 2 squared. It always factors into the variable, the square root of the x squared, which is just the variable, plus, because that's the number, that's the sign, excuse me, in front of the 4x, and then the number that's in my binomial is always half of b. So that's why I write it as 2 squared in that second line, is to remind me that it's the 2 that goes in my binomial. Now I take the square root, and again I subtract over the 2 that I need to get rid of, and I get x equals negative 4 or x equals 0. Now, looking at this again with a different one, now I need to add half of 8 squared. So in this one you see that I've added 4 squared to both sides. I leave it as 4 squared on the left. I go ahead and add 16 on the right. My binomial is x plus 4. So it's the variable then whatever this sign is, if it was minus 8x, it'd be minus down here, and then my 4 drops down. Taking the square root, I get x plus 4 equals plus or minus, excuse me, a positive or negative 4. Subtract the 4 over, and I get x equals 0 or x equals negative 8. Here's another example for you to work with. Okay, by the way, this should be a positive 8 and a negative 2. Alright, now completing the square in functions is not much different, except we don't add anything to the other side. This is not an equation, this is a function. So the way I deal with this is I always like to group anything with an x. So I put a set of parentheses around my x squared plus 10x. Now I'm going to be adding a number inside, because I always add to complete the square. I'm going to be subtracting that exact same number outside. Now, what do I add? Well, I still add half of my b value squared. So inside the parentheses, I add 5 squared. Outside the parenthesis, I subtract 25. I can rewrite that as the binomial x plus 5 squared minus 25. Now this would make it nice and easy to solve. If I wanted to set this equal to 0, solving it wouldn't be too difficult because I've gone through this process. But really the main reason to do it with functions is it's now in vertex form. So when we have that binomial squared plus or minus a number, it's in vertex form. I can read off my vertex really easily. It's the opposite of this number with the x, and then this is my y value. So my vertex is negative 5, comma, negative 25. So let's do the same thing with this quadratic function in order to put it into vertex form. I like to group my x's. So x squared minus 4x goes in a set of parentheses. The plus 2 doesn't have an x, I leave it outside. Inside the parentheses, I add 2 squared. So that means outside the parentheses, I subtract 4. Rewriting it, I get x minus 2 squared minus 2. So my vertex is 2, negative 2. Again, it's always opposite this number, and then here's my y coordinate. Here's one, a lot more complicated because of this 2 right up here. So after I group the x squared and the x term, you need to factor that 2 out. And notice that it came out of the 32 as well. Oh, I got a problem here. That's not supposed to be a 2. That's supposed to still be a plus 5. Okay, so these numbers are going to be a little bit screwed up at the end. But we go through the process. We add 8 squared because that's half of 16 squared. Notice I didn't subtract 64 though. The reason I subtracted 128 is because this 64 is multiplied by a 2. So I actually have to subtract 128. So this number is wrong because that's supposed to be a 5. So this number is wrong. But hopefully you get the idea. When you have to factor out a number, as we did with this 2, it's going to change the number that we subtract at the end. It's not 64, which is inside the parenthesis. It's 128 because that 64 is multiplied by 2. Okay, so now's your chance to work on some of these on your own. I'll see you in class, and I'll see you online.